Almost everybody here. Hey, my name is Melin. If some of you didn't catch it, I was arranging this with Richard, and I just want to say I completely agree with everything Richard said about Go4. I really love also working here.
Did I say that there was jobs available? I don't even remember.
Yeah, you did.
Okay,
There's jobs available. Yeah. Okay, so I just wanted to tell you something about WebAssembly today. I'm not really a guru about it, but I just got interested in by reading some blog or some coworker told me about it, and then I did some digging, and I wanted to share you with what I found. So I'm basically going to tell you what it is and what can you do with it, and probably make you a little bit more prepared for the future when it becomes production ready. This thing is really happening. It can be tested and played with today, but it's still in development. So, is there anyone? How many have you heard about WebAssembly? Okay, pretty many. How many have you? How many of you have fiddled with it? Okay, that's what I thought. Yeah, me. Teemu isn't here. I don't think from Go4.
Nope.
Yeah, okay. He would have said yes. But okay, what about Asm.js? How many of you have heard about that? Okay, and has anyone done anything with it? Asm.js? Yeah, a little bit. Then this is interesting for you, this WebAssembly stuff. And oh, by the way, the logo there, it's not official. There is no official logo yet. So I just picked one from the GitHub issue topic, WebAssembly logo, where people just posted tons of logos, and I think that was cool. So a little bit about history. So first, Mozilla did Asm.js, and Asm.js is, some of you know, it's a subset of JavaScript. It's a specification for writing JavaScript components in a way that can be compiled with static typing. So it's just JavaScript that is optimized for the JavaScript virtual machine in the engine, in the browser engine. And then Google did pretty much simultaneously did something similar called PNACL, or Portable Native Client, which is completely new ecosystem, and it needed a completely new implementation from ground up. So to kill the competition, people from Apple, Mozilla, Microsoft, and Google started working together with WebAssembly, which is now based on Asm.js. So what it basically is, it is a it is a assembly-like language for web. It aims to be the bytecode for web, and it leads to that it's faster to parse and faster to execute than JavaScript. It is basically Asm.js made right. When I said about the assembly language, it's not as hard to read as assembly language, which some of you may know or be familiar with. Is there anyone who has written assembly language? Some of you? Okay. It's not that hard, I think. But it can be written by hand, but it's meant to be a compiler target. And Asm.js made right, when I say that, it means that it's made in collaboration with all the major browser manufacturers, so it will be actually working probably in every major browser. And it will lead to faster decoding and better performance than you get with Asm.js right now. Okay. WebAssembly has many features, and not all will be in the minimum viable product version of WebAssembly. There's still lots of stuff to do, but to mention some of those features, it will have full threading support, and at some point it will have integrated garbage collection, which means that you can use any garbage collected language and compile it to WebAssembly when the compiler is ready for that, if somebody does the tool. And it will also have DOM integration, so yes, you can manipulate the DOM with it. It will have multiprocess support and source map support, and lots of compiler level stuff and low level stuff that I'm not going to talk about. And you can do lots of cool stuff with it that you cannot do with JavaScript, but still it's not the end of JS. Really, it's not, because almost all websites today use JavaScript, at least at some extent, and browsers need to keep supporting it. So I don't think, because JavaScript ecosystem is so huge that WebAssembly ain't going to take it down pretty soon, or never, probably, I don't know. But it's also really hard to see a world where every developer that writes something for web writes it in C++ or Java when there's JavaScript available and it works in every browser today. And I think WebAssembly might become most popular in the gaming industry, and also in some development houses like Go4 or Vincent or anything, because they do some very large and that probably for the public sector, some projects that probably would benefit from using WebAssembly there. I don't know, future will tell. But what can we see in the future then? It's probably we will see these different combinations. We will see HTML, CSS, JS, WebAssembly applications where some of the modules are written in JavaScript and some of the modules are written in WebAssembly. Then there will be some full HTML, CSS, WebAssembly applications, which will have all the programming logic written in WebAssembly, so the source code is something else than JavaScript, maybe C++, or maybe Java or something else. Then there will be most definitely some WebAssembly-based frameworks and libraries. If you think about React, maybe React could benefit from doing the virtual DOM diff algorithm in WebAssembly for the performance sake. I don't know, but maybe that could be some use case for WebAssembly in today's applications or today's frameworks. And then there will be, of course, some heavily extreme experimental shit happening. One might be something like compiling the whole V8 engine into WebAssembly, and so you could browse while you browse. I think that was actually an April Fool's in Badass JavaScript blog a few years ago, and now with WebAssembly it could be actually reality somehow. Somebody could actually do that. Then I'm going to talk a little bit about the use cases. There are some pretty cool use cases for WebAssembly, mostly cases where heavy performance is needed. So I'm going to read this because maybe people from the back on the back don't see it that clearly, but it would really web would really benefit from using WebAssembly in image and video editing, games, game portals, heavy 3D, peer-to-peer applications, music applications. I think this is really cool, this video and audio codecs, because today you have to have an audio or video codec installed in the browser or on your computer, but in the future it could be a developer could use any formats for video or audio, and if they had the codecs in WebAssembly, so it would just execute themselves in the browser. So I think it's really cool, and I think I can see some image recognition applications for WebAssembly, also like video manipulation, VR, CAD visualization, simulation, emulation. Also, this is pretty cool if you could emulate POSIX user space environment in WebAssembly. It has tons of cool stuff you could do with it. Developer tooling will be most definitely made in WebAssembly. I'm pretty sure about that. Remote desktop and encryption, decryption. What about you guys? You have some projects right now. Can you think of any application where you could benefit from tool like WebAssembly today? Does anyone has anything in mind? Okay.
I don't know about the situation, but I was thinking combining like dark language to WebAssembly.
Yeah.
Have you seen
Yeah.
anything like that? Could be kind of a
Yeah,
generic
dark
target for something.
that's something that I have thought that might happen. Also, people might start compiling JavaScript to WebAssembly. That's also very. If they want just more performance, they compile it to WebAssembly. That might happen. I don't know. Future will tell. Any other ideas?
You could like try to port Webpack to WebAssembly
Yeah.
to improve the performance, which sucks at the moment.
Yeah. That could be that could be one thing. Yeah. Okay. More about in the. If you have some questions, maybe talk about that later. But okay, but using WebAssembly today is pretty much you should stick with ASM.js, because ASM.js has the best tooling for the same kind of work right now, and ASM.js syntax is pretty much similar to WebAssembly syntax, so it's quite easy to compile ASM.js to WebAssembly. There's already tools for that. So doing stuff in ASM.js today is probably the right path to go if you wanna try WebAssembly. But you can also use other tooling. I'm gonna show you a small example with it, using CLang to produce WebAssembly. The format is still changing, and it's not supported very well right now. I think all the major browsers have, at least in nightly builds, they have some, or in some developer version, they have WebAssembly support. And you can try it. I have a Chrome Canary where I'm going to demonstrate it a little bit. Now there's the best toolkit for WebAssembly right now is Binarian. And you should really use that if you want to learn to use WebAssembly. So this is the workflow, how it should go in WebAssembly projects. I'm gonna show you also the ASM.js way, but this is how it would work if you had the right tooling, and the tooling would work like it should work. So you write the source in C or C++, and you compile the source to the .s format, which is the LLVM WebAssembly backend format, and then you use the Binarian tool to convert the .s format to WebAssembly text format, which is the S expression format. And that's not the final, if you know what S expression format is, but that's not the final text format for WebAssembly. They haven't decided what the final will look like. Then you compile the WebAssembly text format to binary, and then you can use it in the browser. At the moment, you have to use some tool like fetch or just Ajax request to get the WebAssembly module and instantiate it with the WASM global variable. In the future, it would be cool. I think it will be working that way, that you can use ES6 style imports. I think that will also revolutionize web development at some point when you can actually import things in JavaScript in the browser code live. Okay, then I just demo a real quick how it works. Let's see. How does it look like? Is it big enough? Yeah.
Yep.
Okay, so this is my source code. I have awesome C source code here. So there's just one add function that takes two integers and adds them together and returns it as integer. Okay. Then I have this app.js, which I have just one HTML file that has this app.js, which fetches the add.wasm and then it instantiates it and adds it to the window object so it's globally available. Okay? Then I'm first gonna show you the CLang path, which would be the the actual way to produce WebAssembly. So I have just this small build script and it looks like this. I first use CLang to produce the .s format, as you can see, there's the .s, and then I compile it to WebAssembly text format. And then I have this WAST file, and then I use another binarian tool to build that WAST file to WebAssembly binary. Okay, then I just run it real quick. Build. And what we have here is now the S file and the WAST file and the WASM file. We can check out what the S file looks like. It looks like this. So, as you can see, here's the function name and some parameters in 32-bit integers and the result in 32-bit integer. Okay, this is the LLVM backend for WebAssembly. And then we compile it to WebAssembly text format, which was the S expression format. It looks like this. So here you can see this almost resembles JavaScript somehow. You have add function and two parameters and result in integer 32 bits, and you add these things together. And then it's compiled to WASM file, which is binary. Okay, then I have just run script which opens it in Chrome Canary. It doesn't have anything fancy, it just has this console. Can you see this console output? Yeah. Do I have to zoom it more? Okay, here. So that was the code I showed you. Now we should have add in the global space. And as you can see, we have add function and its source code is native code. Woohoo! We have WebAssembly. Yay! And it looks like this. It's the same thing happens with the built-in functions like object.apply.
Can you move the console to the top of the screen?
Of course, I can open it like this. Better?
Yeah. Thanks.
Okay. So now we can try add something. We add like 1 and 2 and it will be 3. Then I can try, yeah, it works. But most definitely I think it's interesting because it works. It's really in development, this whole project is really bleeding edge. And I can make something that works. I'm really proud of it. And then this is the max of 32-bit integer. This doesn't happen in JavaScript, I think. But then when I add 1, it overflows like integer should. So, so it works like it should be. But this is something I haven't dug deep enough. I don't know how the error handling is gonna work, but if I put something like cat here, and then 2, it will be 2. If I just put cat there, it's 0. So it basically, if it doesn't understand the type, it interprets it as 0 for some reason. I don't know if it's because it's in development, or is that actually a feature? Does it have to? Is it intended to work that way? I don't know.
It could be that it has the function, a signature, and then all those are converted to integers before calling that code. That looks like it's doing that.
Yeah. That's something it does do. I don't know. I have to read more about the documentation. You can read about it too and see how the project develops. But okay, then I show you real quick the mscripting way. We have this other build script. First, I'm gonna clean this previously built stuff. Okay, I'll show you this. So we have this cool tool to produce Asm.js called mscripting, and it's really now the best toolkit you can have when you fiddle with WebAssembly, because with CLang you're probably going to have some problems with dependencies, but with mscripting I think you're better off with it. So we use also binarian toolkit. It is a parameter for mscripting, and I say here do only my code, so it doesn't add any Asm.js wrappers, and then I have to tell exported functions, and I have to put the add function there. I don't know why, but mscripting wants everything, every exported function prefixed with Lodash, so I have to use sed here to remove that, so my demo will work. So then after that I have a WASD file, and then I can use it to compile it to WebAssembly binary. So what I have now here is that I have the add.asm.js file, which is the one that is going to be compiled to WebAssembly text format. And it looks like this. This is Asm.js. Compared to WebAssembly, it looks like which look like this. There are similarities. You can see them. It's not, but it doesn't look the same. But there are similarities. So this can be compiled to this pretty easily. So.
Is the tabulation part of the syntax?
Wait a second, my microphone died.
Can't be.
Just a sec. Just a second.
More sausage has arrived.
Okay, I'm just not gonna shout. I don't want to spend the rest of my. Oh, it started working! Yes! Okay, I had just so little things left here. So I'm just gonna run it, and it will work as previously was the same thing here. Okay, we have add, and it works. Yay! Okay, this was about the demonstration, and just some small things I want to say. Just try that out. This is the future somehow. I really strongly feel that this will change things in web development. So install the Binarium toolkit if you're interested, install mscripten, install CLang, do some hacking and experiment, and read some more about that. So happy hacking and read more. Thanks.